Hey, P-Stats, welcome back. Here we are. I know it's exciting. Today we're going to start talking about density curves, and we're going to eventually lead that into how the density curves work with z-scores. And then that's going to be a really big part of what we do for the rest of the year, as I said before. A couple reminders, if you want a copy of the notes, link down in the description. My classes, obviously, you can also get a link to my notes in Classroom. And then obviously hit subscribe, like, comment, describe, put the little bell on, all that stuff all of your favorite YouTubers tell you to do. So we have three mini experiments that I would normally have you guys run through. The first thing is you would roll a die, regular 6-sided die. If your teacher was any good, I would have one right now. You roll it and boom, you'd have it. And then you guys would go up here and you put them up front, and then you'd go through and we'd say, okay, so what would happen? And so we'd kind of have this, 1, 2, 3, 4, 5, 6, and then we'd have, all right, we might have a fair amount of 1s, we might have a few 2s, maybe 3s happen the most, 4s happen that many, 5s are here, and then maybe 6s are here. Okay, and that's what generally would actually happen. You're never going to get the same amount. Most of you would say, well, if it's a fair die, we should get them all. Yeah, okay. And so then you might come back and you'd say, okay, where's the mean going to fall? And it would probably somewhere between here, 3 and 4. Now the question is, what actually happens? And for that, what we're going to do is we're going to take a look. It might help if I'm actually on the right screen. There we go. We're going to just kind of run this long term. And so this is a website where it shows you or can simulate rolling. And so I'm going to go ahead and just click on roll automatically. And as you can see, as the rolls go up, if I kept it going, it modifies. And so here we're at what? Almost 100. And so it's a little bit more like what we originally had. But in theory, apparently the 4s are winning. There we go. The further and further and further you go, the closer you get to kind of what you'd think would actually happen. Okay. And so for that, what we'll end up doing here in a second is that theoretically, and that's kind of what we always talk about in terms of what the actual density curve would look like. Let's go ahead and switch back. Hey, it worked. OBS is a wonderful, wonderful program. It takes a little getting used to, though. So what actually ends up happening is that you get a curve that looks like this, okay? And 1, 2, 3, 4, 5, 6. And it would be even all the way across, okay? And the question is here then, where would how high would this be? What would be your frequency? Okay, and so your height here would actually equal, pardon me, I need to have some more room for my hands. Height would actually equal 1/6. Okay. Other thing that will end up happening here is depending upon how this graph is set up. Actually, let's do this color instead. Depending upon how this is set up, you would normally think your mean would probably be what? Right down here in the middle, right? So there you would think your median or mean and median right there. And so it would be right in the middle. Here, your mean and your median are going to be about the same. It's not going to be exactly the same, but it's going to be roughly. You're going to get, if we were to average all these things out, or if we were to go back here, again, if I actually switch things, if I were to average all of those numbers out here now up over 1,200 of those, we get a number about 3.5. It wouldn't be perfect. Okay. However, when we come back here, we would actually get a number of exactly 3.5. And in fact, our median and our mean would not be approximately equal. They would be actually equal to each other. And so some of what we're going to do is we're going to eventually get in the course talking about how what we're seeing can be extrapolated into what probably is happening with the population. But we're getting ahead of ourselves here. Now, another one is that we'd have a target, and you would have to try to toss a penny on the target. And then you'd go through and you'd measure the penny from the target in centimeters, and you round them all off. Boom, 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 boom. So again, toss, measure, toss, measure, toss, measure. Most people in this, and if you're looking at this, you think that you kind of get something that kind of looks like that. Okay? Okay, great. Because again, we're only taking, in our case, maybe 90 tosses, by the time we take our 30-some students and each of our units through 3. What actually ends up happening here is this. Now think about it. Are more tosses going to be close to the target, or do you think they're going to be actually further away from the target? And you actually will end up getting, you're going to get some people who get it right on. And then it's going to go up and get further. And then you're going to get people, I mean, nobody's going to be that bad routinely. And so it's going to kind of skew off like this. And of course, you get the one person who decides to throw it across the room, et cetera, et cetera, et cetera. So, question is, what happens to my mean and median here? If it's symmetric, remember the mean and the median are going to be the same. If it's skewed, so in this case here, it's skewed right, you might find your median here. But remember, your mean is, what was the term that we used? Follows the outliers. Look it back up. Your mean is going to be off here on the side, because these outliers way out here are going to pull the data towards them, okay? They're not resistant to outliers. It's kind of like when your friends say, hey, it's okay, we can sneak out of school, and they kind of pull you, no, okay. So a couple of reminders here. So in this case, it's skewed right. Okay, your mean is going to be higher than your median. Okay, if it's skewed left, guess what happens? That's right. Your median is, actually let's keep these consistent. Your mean is going to be less than your median. Exciting, I know. Last one. You've got a stopwatch, and you have to try to find it exactly at 5 seconds. Okay? So you go, you know, and boom. You know, sometimes you might get 4.8. 3, you might get 5.12. You might actually get like 4.97. And so again, I have these little round sticker dots. You come up, you put them up. And again, much like what you have here, you're going to have it where generally people are going to get close to 5. Okay, so you might have like 5 here. And you're going to get people who are kind of getting around 5. Now the benefit here is, since you're off of 0, you can actually be on both sides of that target. Here your target was 0, so you can't get negative. I suppose you could, but I mean, the way that we're doing it, we're just measuring the distance from the center. You can't go to this side, so there's no way that we can go ahead and make those things center out. And so you kind of get something that looks sort of like that. Dare I say it looks sort of symmetric, right? And that is called approximately normal. I probably should do this in purple, sorry. I'll put a box around it in purple. I know for some of you guys, the fact that I've just broken my style code is probably driving you right up a wall. Okay? But approximately normal is kind of what we're going for. That's kind of your first target when we come talking about statistics, okay? Now, a couple of things here. Now, let's say, I need a little bit more room, my apologies. Yeah, let's go a little bit more. So what's going to end up happening here is this. Now, label the values 1, 2, 3 standard deviations above and below the mean. And we are going to say, let's say my mean here is 5. So my mean, and this is going to be the notation for mean, X bar. That's the mean that you actually found. There is going to be something called mu, which is the Greek letter mu. So if you're planning on doing a Greek sorority, fraternity, some sort of society in college, you will eventually probably learn all of that. If there's still college when you get there, hashtag, remember, because that was in the before times, when you could go anywhere you wanted without a mask. Standard deviation, S is going to be the standard deviation that you come up with. There is going to be the theoretical standard deviation there of theta, and then you're going to get 1.39. So let's say we have mean of 5 and standard deviation of 1.39. Okay? So what ends up happening then? So what ends up happening now is that we're going to go through and just label this out. So down here is 0 standard deviation, so that's going to be my value of 5. 1 standard deviation is here, and that's going to take me out, so I'm going to add on this. I'm sorry, the point should be here. That's a huge standard deviation otherwise. Good job, Mr. Hayes. Ah, my notes are wrong. That would do it. 5.139. If I'm going to go 2 standard deviations above the mean, I'm going to add another one of those on, so I'm going to end up with 5.278. Check my work. And then 3 standard deviations way over here is 5.417. And then we're going to do the same thing, except we're going to subtract this off. So this would be 4.861, and then I would end up with 4.722, and then I'm going to subtract a third one off, and I'm going to get 4.583. Okay? Great. Now, I asked some questions here about what percentage of data is within 2 standard deviations, the mean, et cetera, and we are going to do that momentarily. Okay? So I will come back to this. But first of all, we're going to do this. Oops. First of all, we're going to pause this, and we're going to pick it up in part 2.